Good morning friends. Last lecture we have to discuss about the non-stoichiometry in oocyte. Okay. In this lecture we have to discuss the last point of the chapter, that is about the titanium monoxide structure. Okay. The titanium and oxygen form the non-stoichiometric phases. Okay. Therefore the titanium and oxygen. Therefore titanium means that is about the Ti, and oxygen it is formed the non-stoichiometric phases, means titanium oxide it is formed the non-stoichiometric phases which exist over a range of composition which exist, means the titanium and oxygen which are formed the non-stoichiometric phases, and these are exist over the range of composition centered about the stoichiometry 1:1 value, about the stoichiometry 1:1 value from the titanium oxide 0.65 to titanium 1 oxide 1.25. Okay, and this is the first point, and this is the 1:1 value of the stoichiometry in this composition. Okay, therefore the stoichiometric composition of titanium oxide 1.00, the crystal structure it can be thought of as, means the non-stoichiometric, the stoichiometric composition of the titanium oxide 1.00 crystal structure it can be thought of as such as: first is a NaCl is a type of structure with the vacancy in both the metal and oxygen sublattices. Okay, you have to know about the sodium chloride, it is a type of the crystal structure and it's with the vacancy in both the metal and oxygen sublattices, means sodium chloride's structures vacancy in both the metals and oxygen sublattice, means oxygen and metal sublattices. Therefore the vacancy of the sodium chloride crystal it is in this. Okay, the 1/6 of the titanium and the 1/6 of the oxygen are missing. Therefore in the vacancy in both the metals and oxygen sublattices, therefore the 1/6 of the titanium and 1/6 of the oxygen are the missing this vacancy. Okay, above the 900 degrees Celsius the vacancy are randomly distributed, but below the temperature they are ordered as shown in figure 5.28. Okay, above 900 degrees Celsius, okay, your crystal structure temperature is about the 900 degrees Celsius, therefore vacancy are randomly distributed, vacancy are randomly distributed. Why it is randomly distributed? Because its temperature is above 900 degrees Celsius, but but below this temperature their order is shown in 5.28. Okay, look at this diagram of the 5.28. This is the layer of parallel horizontal layer, and this is the hypothetical titanium oxide structures. Okay, this is all about the sodium chloride structure and is shown in 1.31. And second is again every alternate atoms and remove along the made by the planes. Okay, this is all about the figure of this layer of parallel of horizontal planes. Okay, then next is in the figure 5.28a. Okay, look at this a diagram. Okay, a diagram, this a diagram shows that the layer through an NaCl type structure. Okay, the layer through an NaCl type structure, the every third vertical diagonal plane has been picked out of the dash line. Okay, in figure 5.28a, that figure shows the layer through and sodium chloride type structure. Okay, this layer through and sodium chloride type structure, therefore every third vertical diagonal. Okay, look at this, every third vertical diagonal. Okay, this is the third vertical diagonals, every third vertical diagonals, every third vertical diagonals plane has been picked out by the dash line. Okay, this plane has been picked out by dash line. Okay, look at this dash line, it shows that this dash line it shows that the vertical diagonal plane. Okay, therefore next is in the titanium oxide 1.00 structure, that every other atom along this dash line are is missing. Okay, that in the titanium oxide 1.00 structure every other atom along these dashed lines are missing. This is illustrated in figure. Okay, this B diagram shows that the titanium oxide 1.00 structure. Okay, in this structure, therefore, the dashed line is missing. Dashed line is missing in this titanium oxides 1.00 structure. Therefore, every other atoms along this dashed line is missing. Means in this structure, therefore, the all the atoms along these dash lines is missing. Means this dash lines is missing in this titanium oxide structure, and therefore it is along with the atoms, and this is illustrated in this figure B. Okay, there is layer is top of the unit cell, the B is equal to 0 or 1, then the layer below the and parallel to be the central horizontal plane of the unit cell at B is equal to 1 half. This is drawn in figure. Okay, therefore your figure it shows that top of the unit cell. Okay, top of the unit cell, that top of the unit cell it shows that B is equal to 0. Okay, top of the unit cell it shows that B is equal to 0, then then or 1, then the layer below this parallel to be a central horizontal plane, the unit cell will be B is equal to 1 half, and then the B value is equal to 1 half. Okay, then this is shown in this figure C. Okay, the new unit cell of the superlattice is a monoclinic. Okay, therefore your new unit cells of the superlattice it is known as monoclinic. Okay, because the angle in the xz plane is not equal to 90 degree. The new unit cell superlattice is a monoclinic because the angle in xz beta is not equal to 90 degree. Okay, therefore look at this figure shows that the angle is not a 90 degree, therefore it is a monoclinic. Okay, next point is when the titanium monoxide has the limiting formula, that is the titanium carbon 1.25, it has a difference defect structure and still based on sodium chloride structure, but with all the oxygens present and 1 in every 5 titanium missing. Okay, in this 5.29 figure shows that the every um, that shows has a different defect structure still based on sodium chloride, but all the oxygens are present. In the 5 point. Okay, therefore the plain circle it shows the oxygen and all the oxygens are present in this figure, that is the structure of titanium oxides. Okay, then oxygen are present and every 5 titanium are missing. Okay, therefore in this structure therefore the 5 titaniums are missing. Then next is the pattern of the titanium vacancy is shown in figure 5.20, 5.30. Okay, this is the pattern of the titanium vacancy. This 5.30 figure shows that the pattern of titanium vacancy, and the layer is a type of 5.28, but the oxygen are omitted in the figure 5.28. Therefore the oxygen are omitted, only titanium are marked. Okay, in the figure 5.28 only titanium are marked but the oxygens are omitted, where the sample of titanium oxide have the formula which between this type of titanium oxide. Okay, this is all about the titanium monoxide structure, and this is the end of the chapter. Next time we have to discuss about the problem on Schottky defects and the Frankel defects, and therefore we have to discuss about the unit cell problem in next lecture. Okay, thank you.